on. Okay.
Yeah. Yeah.
Um, acoustic dehydration.
Oh, is that what we're here for?
Uh-huh.
Okay. Yeah. I mean, what do you think?
We're gonna talk about it.
Does it mean anything to you? What does it mean to you?
Oh, don't do that. You're gonna see me turn off my video real quick. Well, I feel like the best way I can tell you what it means to me, Dan, is by singing a song.
But in the noise of the factory floor, he heard a question under the roar. Dan Kelly said, "Who told you it needs fire? Why pay to burn what you could save?
Turn the sound
Down
up.
the pyre. Let the signal do what flames once claimed. They are rising from the wire, hey. Cutting costs, keeping value in place.
Yeah.
Power you can't see, turning waste into a brand new space.
I mean,
Man,
I'm gonna send you that because it's a 3 minute and 39 second song. And then I have another
man,
version, but
dude, spot on.
I know.
And what a way to answer a question with a song
I
that you
wasn't.
made.
Yeah, I did.
You have incredible talents, sir.
So it's the AI, but I appreciate that.
But knowing how to talk to the AI nicely to make it do nice things is
As you
a
know,
talent.
as you know, as you know, yes. Luckily, I didn't have two songs. Whoop, whoop. Yes, I did.
Dan
Oh,
Kelly said, turn the fire down. Let it go, dry with sound. Make the molecules move through the air, not the flame. ADAR in the room, changing rules to our name. From heat and hurt to a cleaner design.
Oh yeah,
We
gonna work out for
dehydrate with
this.
oh,
precision
this is
and we
totally.
keep what's inside.
Okay, I'll send both.
I'm pretty sure we can license that to Peloton and just call it a day. Just call it a
My job is done.
day. I mean, that is a complete mic drop moment.
There's some. I use Suno AI. It's very.
Yeah,
You just got to prompt it the right
that's
way.
what makes the songs.
Mhm. They just came out with a V 4.5, so new model dropped. Had to try it out. Dan, what is acoustic dehydration and why is it replacing industrial thermal drying? That's what we're going to talk about today. You excited?
I've never been more excited in my life.
See, I can never tell if you're being serious, but I love it. I love it,
I
Dan, because I think that's what this audience needs to hear. Seriousness, possibly. Mic drop again, mic drop again. Dan, I think there's an industry blind spot, quite frankly. Can I call you Frank?
uh call me Roger, but Frank is fine.
Okay. Dan, you've spent time
Yeah,
inside some of the most, I think, operationally complex environments in business. Would you agree?
I have been involved in a lot of complex stuff
All right. Well, when you look at,
in multiple continents and multiple theaters. Yes.
yeah, it's less about you now. Okay. All right. What made you look at industrial drying? I'd say like a process that's been largely unchanged over a century, and then conclude that the entire industry has been solving it wrong.
Well, part of the problem here is that it's a thermal drying is a century old technology that has never really been looked at. And one of the reasons it hasn't really been looked at is because it works by the function of flame. But what it does very poorly is be energy efficient and also retain nutrient value, meaning maintain the value of what you're actually trying to dry. And one of the reasons that I think we'll probably talk about later as well is there has not been a disruptive technology to this space for years, actually at an industrial scale versus simple little mock-ups and MVPs. And so what got me looking at it and got the entire team looking at it is that one, it was part of the agriculture sector, which is always a laggard in innovation from an implementation of innovation. Farmers are some of the most entrepreneurial people, but they're specifically for their own farm, which is wonderful. But the industry as a whole for innovation standards has always been the laggard versus other industries. That's all. It's just a fact. And the bottom line is, I viewed this as the most energy intensive technology that was in the industry that was already a laggard. So I wanted to attack it because it's a platform play. So that's why I focused on it.
I like that we shift from humor to seriousness really quickly. It's one of the things I value in our what's the phrase? Not collaboration. Dynamic. Our conversational dynamic.
You
Okay,
have to have humor to set the tone
you're not wrong. You're not
and
wrong.
sprinkle in a little seriousness once in a while.
Well, let's talk about sprinkling in some more thermal drying because that has been an industrial standard for generations. I think is a safe phrase to use. What's actually wrong with it, and why have food producers, waste processors, municipalities simply absorb those costs rather than, I guess, demanding something better is the way to phrase it.
They've absorbed it because it's their only option. And again, this kind of goes what I was into before. I mean, over a century, we've assumed drying meant heat, and there was no other way to get that done. And instead, we're using acoustic shockwaves to do it. And so ultimately, we're just using another natural principle, flame being a natural principle. We're using a different one, which is called sound,
Yeah.
to create an effect in which we're targeting a specific molecule on the feedstock that you're trying to process. And that molecule is water. And that's what we're ultimately targeting. And so the problem is that no one else has had anything else to really attack the industry at an industry level. And so we don't believe that you should actually harm what you're trying to process. And that is foundationally why we came across our technology and why we're implementing it globally.
I have a question, Dan.
No questions here.
Yeah,
No questions allowed.
I have a statement.
But go ahead. Yep.
So those two songs that I played, is that acoustic dehydration? In its most literal form. So could we play that music?
Are you suggesting that that song you created was dry? Was very dry?
That's good. Is that a pun?
Did you like that?
I do. Or that it's like like that's the process of acoustic dehydration. What do? You just press play.
Just press play.
Yeah.
Make something dry.
All right. Okay. Okay.
Dry
okay.
humor is extremely effective.
Oh my gosh, I gotta write that down.
You like this?
Dry humor. Okay. What's being lost? Like beyond energy costs, like thermal drying, it destroys nutrient value, right? And the feedstock, like how significant is the loss in practice, and what does it mean economically for companies that I guess are on the receiving end of that degraded output?
Well, I'll just use one use case as an example, and something we've talked about before, and everybody understands what it is. So this is why I talk about it all the time.
Yeah.
And it's manure. Manure is a wonderful fertilizer, has been for centuries. That's no hidden secret. What's very difficult with manure is the fact that 90% of manure, on average, plus or minus 2%, is water. And the water makes it extremely difficult to transport. And the only way to dry out that water historically in the industry has been with heat. And the problem, though, is when you use heat, it's extremely expensive. There it is. There's the poop emojis. You couldn't hold yourself back, could you? You couldn't.
I was looking so fun. Go ahead. I'm sorry. I didn't want to mess up the train of thought. I didn't want to soil the
Nothing soils the environment.
I'm sorry. I apologize. Let's be serious. Come on.
Ultimately, yeah, it's really hard with you, actually,
I
which
think
is why people enjoy watching us. This is why so
Yeah.
many people subscribe to our stuff. I mean,
Yes.
I think we should just make a YouTube channel talking about poop all the time, and we do great.
Yeah. I'm gonna write that down too.
I think we're onto something here.
Poop. Poop.
Ultimately, listen, when people are using thermal heat to dry a product like manure, number one, it's extremely expensive because fossil fuels are expensive. Two, it's horrible for the environment. Three, you have to buy a $5 or $10 million piece of equipment to do this, and so it doesn't make it economically feasible for a lot of individual farmers, as an example, who are actually producing the manure at their in their livestock. Um, and four, there's
Got to shout out you got to shout out the farmers.
shout out to the farmers,
Yeah,
or
always.
if you want to be called a grower, that's fine too. All all are welcome here. All are welcome, all are welcome to the podcast.
Yes.
Um, you are killing the nutrients that makes them economically viable, aka makes them worth something. And so when you're using heat, you're basically hitting yourself twice on the balance sheet. Number one, buying the equipment itself was extremely costly, extremely expensive to maintain, and extremely expensive to run, right? But number two, you're actually killing the nutrient value, meaning you're getting hit twice in the middle of the balance sheet when we think about this purely from an economics perspective. So why would you not want to buy something cheaper to run, safer, and better for the environment that ultimately creates a more profitable output? And so what we're really doing and what we're so passionate about is that we're unlocking these value streams for the producers that are already producing these waste or side streams. They're already doing it. Um, they just can't move the product. They can't distribute it because it's impossible for them to process economically. And so again, going back to this manure concept, for people that aren't coming from the industry, let me tell you an example. In Nebraska specifically, we just had a team of people out there looking at hog lagoons, uh, all sorts of lagoons. Not pretty messy business. It'd be an episode out of Dirty Jobs,
Mm.
A&E. Forget the
Mm.
guy. He would love it.
Uh, 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 Micro.
Yeah, yeah. We should get a deal with Micro. He'd find ADAR fascinating. Put
Oh,
all the nasty stuff in here, and actually out comes a perfectly odorless high protein
he used
powder.
to be the spokesman for my dad's first pharmacy.
No way.
Yeah.
Cool.
Hey, let's work on it offline.
Offline.
Yeah.
Anyway, creating a dry, nutrient-rich pellet,
Mm.
meaning something like that you can transport in a truck, anything of that nature, that we're eliminating that 90% water weight but keeping all the good stuff in there. That was literally the premise of the entire technology coming to form. That was our only focus at the time, years ago. And it still remains a massive, massive opportunity. Because what's happening in Nebraska, as an example, farmers are spreading out this manure because they're producing so much of it in their livestock.
Yeah.
They're spreading it out or they're giving it away for free in their fields. And the massive amount of nitrogen that is inside of the manure is literally burning up the fields, meaning it's killing the fields, meaning it's almost a triple whammy here. Because not only are they killing the nutrient value with it, they're actually just spreading out this liquid manure onto the field and it's lowering their yield, meaning lowering food supply, meaning lowering an entire supply chain and making everything more expensive for everyone in the world. And so if we can give them an option of how to distribute this product, this byproduct they're already making,
Hmm.
and make money from it, well, that's where you got a winning solution. And they're helping the environment at the same time. But helping the environment, quite frankly, is a byproduct of simply making more money.
Yeah.
And you've heard me say before that that's the only way that clean technologies actually get implemented at scale. And that's the reason that we're so passionate about what we're doing.
That's fascinating. All right, plain language about the technology, like without any technical jargon for someone like myself. Like
Mhm.
what is acoustic dehydration? What makes it supersonic? And what physically happens to organic material, like when it goes through your system, ADAR system specifically?
So we're using acoustic sound waves instead of flame. And how we're doing that is we are inserting the material that you're trying to process. And instead of it having go on a belt into a drum dryer, which is basically this rotating dryer with flames just shooting at it,
Hmm.
right? And then out comes the other side, which again, that's an okay technology for people that don't care about nutrient value or whatever. But instead, Our technology is running. There's only one moving piece for the most part in our technology, and that's the turbine that's creating a massive amount of airflow. Okay. And that airflow is being constricted into a tightened airspace. And on the outcome of that contraction of airspace, meaning an actual cone or a converging, diverging, we call it Venturi theory, cone, we also call it the throat. There's an explosion happening on the backside. And that explosion that's happening is creating this cavitation, these sound waves that are just shaking an incredible speed and frequency. That sound waves, got it.
Yeah, I'm trying to keep up with emojis right
I
now.
love it. We all learned in high school, at least we should have, long range frequencies, short range frequencies, right? Think about the shortest range frequency you can, and this is creating this vibration,
Okay.
right? The industry is called cavitation,
Mhm.
industry term. A lot of people don't know what that means. It's fine. All you need to think about is really short sound waves attacking a problem.
Okay.
And that attacks, what we're doing is we're literally attacking the water molecule. And so we're literally creating a material separation
I
between the
press,
water,
press the wrong thing. Go ahead. The
the
water.
water, we're separating the water molecule from the compound that you're trying to maintain. So if we use manure as an example, the poop,
Yeah.
there's the poop emoji, with
I can't go that fast, Dan.
with the water.
I have stage fright. I'm just kidding. Okay, with the water. Yeah.
Thermal energy hits everything all at once, just attacks everything. We are like a sniper shooting at a specific target, and that is the water molecule. And that's quite frankly what makes us very different. We have two different products.
Sniper.
That's
Okay, two products.
that is not a sniper rifle.
That's all we got
That is a
on
water
these.
pistol.
That's a squirt gun. But
That's a
yes,
squirt.
yes, you're right. Go ahead. Two
Uh,
technologies.
we have two different technologies. One focuses more on a traditional mill mixed with our Venturi theory, and that works well for very hard substance like wood chips, etc. And then the other product is purely just using a Venturi theory. The bottom line is both products do the same outcome. It's just one's better for one use case, one's better than the other. That's all.
All right.
But that's how it works. And the only moving piece in this entire equipment, quite frankly, is that fan or that turbine. And that's what makes it so cheap to operate, cheap to maintain, and cheap to run because all we need is electricity.
Interesting. All right. You've mentioned a 70% cost savings. Is that right? 70% over conventional drying. Drying. Is that right?
It yes,
Okay.
depending on the use case,
Yeah,
exactly
fair.
right. Up
Fair.
up to 70%. Yep.
Can you walk us through like where the savings actually comes from? Is it energy, speed, labor, combination? And how does that math hold up against different like feedstocks, I guess?
So it's energy consumption is a big one.
Okay.
Um, Especially depending on where you are. Or the batteries.
I actually had that ready to go.
You had that ready? Okay. Yeah, okay. Uh, Fossil fuels in Europe,
Uh-huh.
far more impactful even than in the US. Obvious reasons, geopolitical factors going on. So that statement even makes more sense when we're even talking in Europe or anyone that does not have a consistent fuel supply. Um, so that's number one. Number two, it's the material integrity or the degradation of the specific material, the nutrient value. I can't speak about that enough. If people don't care about that, then we're probably not a good fit for the customer, quite
Yep.
frankly, right? Uh, Number three is the labor and the ongoing costs to maintain the machine. Those three big buckets
Okay.
are what really create that number.
Yeah. All right. I misfired with the rock emoji. I didn't want to overlook it.
Well, I mean, we do process rock as well. That's
Okay.
why we can in the mining industry because we pulverize everything around a rare earth or precious metal.
I'm
Uh,
back. I'm back, baby.
and so we extract all the good stuff from basically what do we call mine tailings?
Yeah.
So the
Yeah.
rock. Yeah. So if you're a mining industry, you like gold, you like platinum, you like all those things, you like rare earths and all these national security elements. We're a good fit for that too.
That was good. That was helpful.
Yeah.
Pick ADAR. Okay, do you get it? Do you get it?
I, you know, I actually got that one because you use picks for mining.
All right. All right. Acoustic technology.
Zoom came in handy right there. You've done that before.
If I really want to get serious, Dan, you got to just rock out a little bit. But
Oh
yeah,
my gosh, how do you know all these things?
are you serious? Do you is that the question is how much time do we have? Okay,
Right.
peace. Just kidding. I'm not doing any more. Yes, I am. Let's go. All right, so the acoustic tech isn't as a concept isn't new, but like the combination of engineering, materials, and market conditions made this the right moment to bring it to industrial scale. Like
Yeah.
what would have made this impossible 10 years ago?
Yeah, I wrote something down here because someone told me this a long time ago, and I can't give them credit because I don't know who it was, but it was back in the beginning of my investing career, about 11 years ago or so. Um, some guy I met at a conference, honestly, but it's a concept, it's a sentence that has never left me. And I'll just read it verbatim because it says a concept can be scientifically sound long before it becomes commercially viable. And that is 100% true, obviously. You can, scientists, engineers, etc., can come up with the greatest thing on earth. But if the market isn't ready for it, aka there's not a demand for it, right? Or two, you don't have the right systems process or production level readiness to make it commercially viable, it's not a fit. And so ultimately, we know the time is right. The entire market is looking for ways to become more cost effective, and they're looking to create new revenue opportunities from sources that they already have.
Hmm.
And that's not the market just that are ultimately looking at their environmental impact or sustainability. There's a component to that too. No, these are people that literally have a problem and they're trying to find a solution. Outside of manure, we can talk about chickens as an example. Chicken waste. So whole chickens, the carcasses, the blood, there it is.
You set me up.
Is
You
that a
set me up.
chicken? Or is that a rooster?
It said chicken.
It's chicken. That's chicken, I guess. Uh, the blood, the guts, the feathers, the bones, all the things that we cannot buy or don't want to buy.
Yeah.
We do want to buy that. That was a chicken leg. We don't want to buy at the store. What do you have to, what do you do with it today? Well, typically producers just give it to hogs. Hogs eat everything, et cetera, right? But there's a real issue with that. We don't have enough time to talk about all the environmental effects and the leaching into the groundwater, et cetera. And I won't air a lot of the dirty laundry for the industry.
Yeah.
But let's just say there's a lot better ways to process that byproduct or that waste stream to ultimately make a very, very, very valuable product. And so ultimately, just using numbers as an example, it costs these producers $90 a ton typically on average to throw these away, to throw this byproduct away. They can turn it into a 5,000 or even a $25,000, whether it's a premium pet food in that 5,000 category or a nutraceutical
Hmm.
revenue stream. And so again, this is just a no-brainer economics deal. And we just put our technology right in the middle.
Big brain.
Big brain stuff.
I want to say I couldn't do what you're doing, where you're like seeing these things pop up on the screen and continue talking. So I hope it's not too much of a distraction, but
It's not a distraction at all. I mean,
you gave me an inch.
yeah,
So that's all very fascinating again. You've had leadership fly in globally, like you were telling me from Japan, like shipping across the Atlantic. What patterns are you seeing from who recognizes the technology fastest, and what does that tell you about, I guess, where the early market is actually forming?
great question. What I would say across the entire client base would be they are people that have a pain, meaning they have a supply. What was I just talking about? They have a byproduct or a pure waste stream in which they know it's either a pure expense or they're not getting enough value from, aka they don't know what to do about it. It's a nuisance. That's number one. They have a problem. Number two would be they ultimately have a culture that focuses on challenging the status quo. And that is a cultural element that is not a forced element. And so that's number two. And again, from Dubai to Japan to India to Australia. We've literally hit every corner of the world here with interest, literally shipping stuff around the world to us to test and to deploy. Those are the two main foundational cultural elements. They've got a pain
Yep.
and they have a desire to challenge the status quo.
Yeah, that tracks. All right, what about the IP moat? You've secured patents in the US, Mexico, Canada, Europe. Is that pending? You have a patent pending?
Europe's pending, yep, and
Yeah.
we have multiple patents, not just one, by the way.
Yeah,
Yes.
yeah. If you roll the tape back, I said patents, patents, but I appreciate the clarity.
Yeah, no problem. Just want to make
And
sure that we're clear here.
yeah,
Yeah.
yeah, yeah. And do you have a trademark, by the way?
Yes.
Okay, good, because now I can do that. All
Yes,
right.
we do.
Yeah, that's the only reason.
I was waiting for a punchline there. I was thinking
Yeah,
about the reason I paused is because I was thinking about where's he going with this.
there's no emoji for patent, but there is for trademark. Got nothing to do with my question. In practical, I mean, it's not nothing to do. Okay. In practical terms, what does that protection mean for ADAR as larger players start paying attention to what this tech can do?
We have had all the big guys watch us. We know this either because they've directly contacted us or we quite frankly are aware who's looking at our website via all the different tools
Sure.
that the market provides there. Or three, quite frankly, direct investment interest and offers into the company.
Yeah.
Um,
I didn't mean to say no. I didn't mean to say no. Just popped up. Well, that's humbling.
It is humbling. And so, what these patents do for us, I mean, that was your question. I mean, they
Yeah.
ultimately just buy us time and leverage.
Yeah, sure.
There, I will just tell the market publicly right now that there is an incredible amount of IP that we will never patent
Mhm.
because we have no interest in telling the world how our black box works.
Sure.
We will use the trade secret international law for that. And another reason is it's impossible. No, it's not impossible. That's the wrong way of saying it. It's financially infeasible
Mhm.
to patent in every country in the world. Nobody, even the big guys don't do it. Even Bayer, BASF, they don't do it. It doesn't make sense. And so I'm just going to share that we are patenting the hard components, the utility components that gives us the broadest coverage possible. That, yes, is absolutely critical to our technology. But without knowing how the technology operates, which is both human knowledge as well as, quite frankly, unique software that we've developed to
Sure.
run the product, you won't be able to get anywhere.
Yeah.
But
Damn
what's so
right.
cool about it is that we've got that throat I was talking about before, the cone, the converging and diverging cone, which is just as it sounds.
Yeah.
That's creating a Venturi effect. And quite frankly, that is what even retail grade leaf blowers are using today. So what my point is that there's a there my example is we are patenting those in which gives us the broadest net and the
Yes.
broadest coverage. And people ask me all the time, well, Dan, if companies like Milwaukee could be potentially infringing on your patent without even knowing it, isn't that an opportunity? And I say that's an example of a licensing opportunity, which is the only reason why we would patent something
Yeah.
is when we actually want to license it out.
Yeah. Well, that parlays into your vision now. You've described ADAR not as a machine company, but as a recurring revenue industrial services platform. Your words. What does that distinction mean in practice, and why does it matter for the industries that you're serving?
Well, um, what it means is that we're just not a hardware company, and this is for two different reasons. And let me explain, depending
Yeah,
on who I'm speaking.
go ahead. Go ahead.
Yeah. Depending on who's listening right now, it doesn't matter because I'll explain to two different large buckets. One, I'll talk to investors for a second. Those limited investors that we're allowing in. For my shareholder base, what this means is a hardware company typically can demand a 3x multiple when we talk about company valuation. A services business all day long can demand 10x multiple. So part of this is self-serving, quite frankly. We can drive the greatest enterprise value by having a recurring revenue business versus a slow, clunky hardware business that has many endpoints of failure because everyone wants a hardware that works just a little bit differently for their individual environment, right? Much better play, and now I'm speaking to the customer side as well as the investor. Much better play for us is to build very few SKUs, if you will,
Mhm.
2 or 3 different products in which we sell into market. Um, and it gets us out of the hardware business. And what I mean by that is we enter into equipment as a service or infrastructure as a service, like I like to call it,
Yeah.
where we cover all of the hidden costs that come with hardware purchases, such as maintenance, such as upgrades, etc., within that 5-year lease term for companies that actually want our product in their operation and they keep the output material, etc. The other is we're going to enter into a flow rate model. Bottom line is what that means is a usage-based or a consumption-based model.
Mhm.
You don't have to worry about anything other than having a business case where there's a cost to process material that you can resell. And we just capture that cost on material, and it's based on incoming weight. And so what this means is for the industry, for our customers, we convert a very clunky, expensive, slow to generate CapEx
Yep.
budget process into a OpEx where we can walk into companies like we're doing right now, public and private sector, and say, listen, whatever you're spending today, what if we can do that for 50%? And that's our base case. What if we can save you 50%?
Yeah.
And if the answer is we can't, then we go to another customer because there's so much low-hanging fruit at that 50% cost savings concept. Environmental waste and industrial waste and food waste. That this is why we have so much interest.
Interesting. All right. So the last question I have is reframing this overall. If acoustic dehydration reaches the scale that you believe it will, Dan, what does it mean for how food processing and waste industries fundamentally think about what they've been throwing away?
What I would say is we're literally at the industry nexus of having no waste at all, and where waste is actually viewed as a profit stream and not an expense. And it's just that simple. And for every single customer, they're going to have a different situation. And so ultimately for ADAR, it's one of the reasons that I'm such a big proponent and have 100% conviction on a house of brands strategy.
Mm.
Because ultimately someone might have a food waste problem. Someone might have a food waste problem and they just said, well, what does ADAR do with food waste? What does ADAR do with harmful seaweed called sargassum? What does ADAR do with manure? What does ADAR do with rocks and mining it? And we'll have different brands inside of each. And ultimately, it's just to get to the answer for that customer immediately. The same way 3M does it, the same way Honeywell does it. It's multiple brands. Ultimately, our technology doesn't change. It's just the value that we produce for the customer does. And so that's why we're focusing on those industries that have the biggest problem with the biggest need because they have the lowest barrier to entry.
We're gonna take callers now. Janet, you're on with T and D. Janet, you there? Next week we'll have callers. How funny would it be if you just heard Janet? Okay, I think this is fascinating stuff. I say that a lot. Dan, what's our next
That's my
episode?
name.
What's our next episode?
I don't know. What should we talk about?
I don't know. Let's keep the audience in suspense.
What do they want us to talk about? Maybe you could run a poll.
Could
Yeah.
comment below. Smash the subscribe button if you enjoyed, and most importantly, what emoji do you think was the most tasteful? And because I can take criticism, what didn't you like? Okay? Was it distracting? I'm lagging. That's distracting.
That's distracting.
Wow, going so well. Dan, thank you, my friend.
Absolutely.
Always a
Ultimately, I love everybody that's listening because these people actually understand the importance of changing the economics of the entire industry and what disruption does.
amen to
And
that.
and that's it. That is a leggy high five.
See you next time, Dan.
See you.